Hi, good evening. My name is Mariana Nava, and I'm going to talk about statistical analysis done about maguey agave-salmiana micropropagation. So for this experiment, we're going to have the response variable be the number of shoots grown per treatment, and we're going to have one factor only, the concentration of one specific phytohormone. We're going to have our control and 4 different concentrations. We're going to have 5 treatments in total, repeated 5 times each, with 1 explant per repetition. And we will perform a 1-factor analysis of variance, 1-factor ANOVA, with 5 different levels. Our null hypothesis is going to be that there is no difference between the mean of the number of shoot formation per explant in the different concentrations used, the different treatments. And the alternative hypothesis is that at least one mean is different. This is the data that we're going to be using, and it is important to note that this data is hypothetical, as we did not have any significant data that was useful from the experiment itself. The ANOVA is going to be done with a confidence level of 95, which leaves us with a significance levels of 0.05. We can see here that the p-value is lower than the significance level, which means that we can reject the null hypothesis. Therefore, at least one mean is different. To test how reliable the ANOVA is, we're going to test if the 2 assumptions it is based on are true, the normality and the equal variances. For this, we can see that we're still going to be working with a confidence level of 95, which means that the significance level is still 0.05%. We can see that the p-value for both of these tests is higher than the significance levels, which means that we cannot reject the null hypothesis. Therefore, the population is indeed normal and the variances are indeed equal. Finally, to see which is the better treatment, we're going to use interval plots and box plots. We can see that the best treatment will be treatment number 1, as it has a higher mean. This means that there were more shoots grown per explant. And this is further, we can see that it's true because of the Turkey pairwise comparisons. We can see that treatment number 1 is in only a different letter, group number A, which means that they are significantly different. And we can also see on the graph on the right that each combination with treatment number 1 does not contain a 0. So the means are significantly different. This can be set with an individual confidence level of 99.28%. So in conclusion, we can say that treatment number 1, the control, was the better treatment.